for project 1, some more details. We know we calculate polynomial values in 2 different methods. The first one, ordinary method. The second one, corners rule. Okay, yeah. But in our implementation, we want to avoid the overflow problem. Remember the last time? Overflow problem. Yeah. Otherwise, if you do not pay attention to this overflow problem, you get wrong answer. The answer is wrong. Okay, garbage, the answer actually. Now, so we need to make sure the overflow does not occur in our calculation. Now, how do we get that? So here I use Java, because for Python, you do not have this issue. Python already taken care of. So you just do it, okay? Yeah, the integer, do it, yeah. So in Java, we need to use big integer class. Yeah. Here, I just take some, constructors, methods, and I want to explain how to use them. Yeah. The first one, constructor, big integer. First, let me explain why when we use big integer class, then the overflow is gone. Yeah. The reason is very simple. Yeah. Look at the constructor here. When we construct a big integer object, the parameter we pass to it is a string. It is a string. What kind of string? Translate the decimal string representation. So actually, you get a decimal number, but you use the string format of the decimal number, not the number format. It's a string format. Okay? Yeah. So here, let me tell you the difference. The string format. String usually we put in the double quotes for string values. Okay? Yeah. But inside our double quotes, we use digits. Okay? So here, I just write some digits. Okay, double quotes, yeah. Double quotes, we treat it as a string. So that it has these characters. We treat it as characters, okay, to form a string. Yeah. Not a number, it's a special string. What's the difference? The question is, what's the difference? Difference is big. If you use the number, we know the number, you have to use certain number of bytes to represent number, right? There is a data type, there is a size for data type. For long integer, 8 bytes. 8 bytes for long integer. That's the largest we can use, largest integer type we can use in Java. Okay? 8 bytes. But when we use the string format, do we have any limitation for number of characters in a string? In Java, no limit. When you use a string as a parameter, you can use any number of characters for a valid string. Any number of characters, no limit. No limit means no overflow. No overflow. Okay? Yeah. We use the string representation, then the overflow is gone. Overflow is gone. Okay? Yeah. Then, how to do math operations correctly? Then, this Java class takes care of that. You don't worry. So you have this object, you can apply addition, subtraction, multiplication, many different math operations by calling those methods. Underlying strings, underlying implementation, string format, not digit, not number format anymore. That's the reason we don't worry about overflow here. Overflow is gone. Okay. Yeah. So that's the good thing for for, this special class. So I want to introduce this special class to you in this first project. And in my second project, I also need to use this one. So I want to introduce it to you as early as possible, prepare you for the second project. Yeah, otherwise, for the short semester, we may not have enough time for the second project. So I do preparation earlier, okay? Yeah. All right. Then, for the constructor, you need to start with a string representation of a number. And that's easy. So you can do it. 0, when you want to represent big integer 0, double quotes 0. Okay? Represent 1, double quotes 1. Yeah. So then you get that big integer 0, big integer 1, and so on. Okay. All right. So that's the first constructor. Yeah. But the second constructor also useful to generate our data. The second constructor, look at the first parameter number of bits. When we need to generate a random big integer number, we need to specify number of bits. Okay. Yeah. 2, 3, 10, 100. Yeah, you need to specify a certain number of bits. Oh, certain number of digits. Bits, digits. Yeah. Yeah. Right, bits. Oh, bits. Bits is okay because 2 to that. Yeah, yeah. Bits is fine. Yeah, yeah. Equivalent to digits. Yeah, yeah. Bit. Yeah. So the range between 0 and 2 to that number of bits minus 1. Okay, but the second parameter is a random object, Java random object. You can pass it as the second parameter. What's that random object? What's that random object? Yeah. Because in order to generate a random number, you need a random object to do the generation. Yeah. Here, it's simple. Yeah. This random is a Java class, another Java random class. So you use this random class name. So you construct this object first. Here, let's just use this RND equals, then we call constructor. Okay, we call this Java constructor new random parenthesis. Okay, so after this line, we have a valid RND random object, so we can pass it to this constructor, and then we'll provide the number of bits here. We can get a random big integer object generated following the condition. In this way, I do not need to provide my own method. I wrote a method, generate, but we have a constructor here, so you don't need it. So you just, use this way, you can generate our random data. Yeah. Because after that, how do we use this random generator? Remember, 2 places we need to use this random generator. One is the coefficients. Polynomial, the coefficients. Second, x, the variable. The variable value, you also use this random generator to generate these 2 places. Okay. Use this one. Then use 2 different methods. Method 1, ordinary method. Yeah. addition, multiplication. Yeah. Second, Horner's rule. Second method, Horner's rule. Use your big integer. But when you use ordinary method or Horner's rule, you need to use big integer add method and multiply method. Okay? So it's not a plus operator, star multiplication operator, it's not. Okay? So you need to call some big integer object dot add what? Another big integer, right? So you get a value, right? Here, big integer dot multiply another integer value, so you get a big integer with different value. Okay? Yeah. So these two methods, you do addition, multiplication. Okay? Yeah. Then I'll give you the detail, so number of bits. I use number of bits. Okay, yeah. So then the two methods first, they should give you the same answer. But integer exactly the same, no error. Your polynomial value, there is no error. Okay? Exact numbers, two numbers should be exactly the same. Yeah. Then the first method, we expect much slower than the second method. Second, Horner's rule, much faster. The first one, ordinary method. Yeah. So here I like to control the first method. You can choose number of bits, the number of coefficients. You choose certain number of bits, certain number of coefficients. I like you make your response time of the first method close to 30 seconds. The first one. Close to, not necessarily exact, okay? Close to 30 seconds. Okay? So you can choose certain number of bits and a certain number of coefficients. Yeah. To give you response time for the first method, close to 30 seconds. But that's quite long. Okay. For the second one, then you calculate the same polynomial value. The second one should be much faster. Second one, you compare with the first. If the difference is big or not. Okay, so that's the whole project. Question.
So from my understanding, on the project, we will be constructing two methods, which one of them will be using the regular, and then the other one will be using Horner's rule.
Yes.
And then we're comparing the time efficiency of both methods. Is that correct?
Yes.
And that's after you compile it, right? At the very end, it just tells you the response time, or do you want us to get that from the built-in function in Java?
Built-in function.
Yeah. Time.
The time?
The time, right? Time, you can find appropriate function, tell you milliseconds.
Yeah.
Okay? So when you run this method, start the clock, then you call the method. After you finish this method, then check the time, take the difference. That's the response.
So
you want an actual 30 seconds?
No, close to.
Okay.
Just give you an idea.
Close to, yeah.
For comparison reason. Yeah.
So how big is the polynomial?
Polynomial, here I do not have idea, the polynomial, at least 100 degree, at least, 100 to 1000, yeah. But another factor control, number of bits, number of bits for your data size, another factor to control. But here, because I didn't test myself, so I do not have an idea of how slow, but I can try on my computer. My computer is relatively slow, because I use it for presentation, so not very powerful.
But utilizing different computers doesn't matter in this case because we're working with the procedural to see the efficiency of the procedural,
Right.
how much time it takes, right?
Right, for the response time, matter. 30 seconds thing, yeah, because on my computer,
The
30
execution
seconds.
is still gonna be.
Yeah, on your computer, probably 10 seconds.
I thought we were measuring the actual procedural
Yeah.
efficiency, right?
Yeah. So what I like to have between 10 seconds and 30 seconds, that should be fine. More than 10 seconds. Yeah. For the regular method, more than 10 seconds. Because you feel slow enough, right? Yeah, when you wait 10 seconds, you feel, oh, slow enough. But not more than 30 seconds. We do not need that long. Okay? We do not need that long. So at least 10 seconds, the maximum, within 30 seconds. That should be, give you impression, oh, this method too slow. That's enough. But second one, if you do the same thing, a few milliseconds, you will get a few milliseconds.
And you also said that it doesn't have to be on Java, it can be in Python or C++. Right?
Yes.
Okay. But you're just giving us in case we Java.
Right.
To utilize these.
Right.
Embedded.
Right.
I don't know what C++, where, like the.
Secret, how to handle that overflow thing, here I cannot give you helpful information myself. I do not know. Yeah, so actually I prefer Java or Python. I prefer, yeah, Java or Python.
One way around it is just creating an array and continually expanding the array.
That's too complicated.
Exactly.
Too
Why would
complicated.
you even do that?
Yeah, so, all right, good. Any question? Yeah.
You're gonna release like a whole,
Yeah.
criteria for the project and
Yes.
are you gonna provide a sample output that you would like us to be
Like
close
how-
to? So that's what we're, at least what I'm usually used to, at least kind of like a sample output.
Yeah, but here I do not, so, yeah, but in my description, you need to generate the result, polynomial value, and the response time. Then, compare. So that's all I need. In my description, I will put it, but I do not show you my result, my response time sample, yeah. Yeah. I like you, actually, I like you, the reason I like you, for different students, I like you to generate different output. Different display, different views, different view. Oh, one thing I did, I will check your code, some students copy the code, I will do comparisons. Every semester I caught 2 or 3 those students. So that's why I like you, definitely. I like you, each student, you show things different. Input, output, all in different ways. If I notice 2 students same way, then I will compare your code closely, right?
So what's the range of like, randomly generated numbers do you want? Do you want like a specific range?
Yeah, in my description, I will tell you.
Oh, okay.
I will put some numbers
For
there.
both the
Yeah.
coefficients and the.
Yes,
x values.
I put some numbers there.
Okay,
But my first version, I just guessed, okay, reasonable. Yeah.
okay.
Then I may do some testing myself. If I feel I need to change, then I will modify those numbers. Here, I do not have idea. Because this version, this class, I changed the first time. The older version, I use floating point numbers. I never use big integers. Yeah, older version. But here, the reason I choose big integers, because I want to prepare you for the second project. So you can do second project, because it's a short semester. You don't have much time, so I need to prepare you for the second project. as early as possible. Okay, so that's why I modified my old project.